Welcome to qnawire.
We have a bar G that's moving to the right at 2 meters per second, and it's rotating at 4 radians per second. And we want to find the velocities of point A and B, and also want to find the instantaneous center of zero velocity. So first, we can find the relative velocities of A and B with respect to G. So we'll start with VB given G here. And that would just be the length of GB times that omega G. And since that's the only omega we have, I'll just write it as omega. GB or BG is just 0.3 meters. Omega is 4 radians per second. So this gives us a 1.2 meters per second. We can find the absolute velocity of B fairly simply by looking at a Pythagorean theorem, where we take VG and V of B given G, add them together squared, and that should equal VB squared. So VB will equal the square root of VG squared plus VB given G squared, which if we put the numbers in, VG is 2, we found VBG as 1.2. This leaves us with about 2.33 meters per second. We can do the same thing for A, and because this is symmetrical, we end up finding that VA with respect to G is just AG omega, and it's again 1.2 meters per second, of course in a different direction. VA will then very similarly give us a 2.33 meters per second, again using the exact same method, since the numbers are the same. But we still need to calculate an angle. So this angle theta that VA is moving in and VB is moving in. So that angle theta there, that angle theta there are the same as these angles below then, where C is just the center of the actual movement of B and A then. So we can look at these triangles and say the tangent of theta is going to be VB with respect to G over VG. And this just comes from the opposite side over the adjacent side in this triangle. And this leads to theta as 30.96 degrees. And depending on how you look at this, it could be that we want to call, usually we call it straight to the right 0, and then rotating upwards the angle over here for A theta. So for A, we would usually call that 30.96 degrees. So I'll write that as theta A is 30.96, and theta B would be 360 degrees minus that, or just negative 30.96 degrees. So if I take the 360 minus that, that would give us 329.04 degrees. So the final thing we want to do here is find the instantaneous center of zero velocity. And to do that, we need to find this length GC in the middle here, which I'll highlight in blue. We can say that this length GC that? GC equals the length GB times the cotangent of that angle theta. We know we have the angle 30.96 for theta, and the length GB is 0.3. So when we put those numbers in, we find that we get 0.5 meters. So this instantaneous center of zero velocity is 0.5 meters away from G.